So the problem I chose is a rod in static equilibrium, which is standard 3.5.1.5. So the problem states that a 12 kg non-uniform rod with a length of 2 meters is arranged such that it hangs at rest against a string as shown below. The string is attached to a spring scale which reads 4.5 newtons of force. The first part of the question asks us to determine the magnitude of the force of friction between the rod and the floor in this arrangement. So in order to solve this problem, first we need to make a free body diagram. The first force is the force of gravity, which originates from the center of mass and goes straight down. The next force is the normal force, which originates from the ground and goes straight up. The third force is the force of tension, which originates from this point and goes straight to the left. And the final force is the force of friction. Without the force of friction, the ladder would probably move to the left. Since the force of friction opposes the motion, the force of friction will be going to the right. So, in static equilibrium, there are two conditions. We know that this rod is in static equilibrium because it says that the rod is at rest. So, the two conditions for static equilibrium is that the sum of the forces should be 0, and the sum of the torques should be 0. Okay, so looking at the first condition of static equilibrium, the sum of the forces must equal to 0. This also means that the sum of the forces in the x direction must be equal to 0. So I'm just going to write that like this. So let's look at all the forces in the x direction. There's the force of friction, which is acting opposing to the force of tension. So you can write that in equation form as force of tension minus force of friction equals 0. Solving for the force of friction, we get force of friction equals to force of tension. The force of tension is given to be 45 newtons, so we can replace that. And then we get the answer to our first part of the problem. So the second problem asks us to determine the magnitude of the normal force acting on the rod from the floor in this arrangement. So going back to our diagram, we can see that we need to take the forces in the y direction now. So let's look at all the forces in the y direction. The only forces that are in the y direction are the force of gravity and the normal force. So we can make an equation by saying Fn minus Fg equals 0 since it's in static equilibrium. And since there are opposite forces, so there should be a minus sign in the middle. So now we can solve for the normal force by saying Fn equals Fg. And we know that the equation for Fg is just m times g. M is given to be 12 kg, and we can take g to be 10. So Fn equals 120 newtons.
Start.
Okay, so the second condition of static equilibrium is that the net torque has to equal to 0. So let's look at the forces that affect the net torque. Any forces that are going through the pivot point are not counted for in the net torque. So the only forces that do affect the torque are the force of gravity and the force of tension. So let's write that down. Okay, and also the equation for the net torque is torque equals to F times R perpendicular. R perpendicular is the perpendicular distance of the line of force from the pivot point. So let's look at the perpendicular distance for the force of gravity. If we extend the pivot point line and if we extend the force of gravity, we see that this is the perpendicular distance of the line of force of gravity from the pivot point. We know that this is 2 minus x, so that means that this will be 2 minus x times cosine of 60 degrees. So times 2 minus x cos of 60 degrees. Now let's look at the tension. Let's extend the line of the pivot point. and this is a perpendicular. So and this will be the perpendicular distance of the line of force of the tension from the pivot point. And we know that this angle is 60 degrees, and by the alternate interior angles theorem, this will also be 60 degrees. So that means that this will be 2 times sine of 60 degrees. So multiply this by 2 sine of 60 degrees. Now we have to look at the directions to find out the signs. So we know that this force of tension causes the rod to move in an anti or counterclockwise direction. A counterclockwise direction is taken as positive by convention. The force of gravity causes the rod to move in a clockwise direction, which is by convention taken as negative. So then we can just put the signs in. And as I said before, the net torque has to be equal to 0, so just set this equation equal to 0. Okay, now what we have to do is we have to solve for x. In order to do that, we just subtract both sides by this. We have to isolate the x. Okay, and Ft is given to be 45 newtons, so we can plug that in. And as I said before, Fg is basically m times g. M is given to be 12 kilograms, and g is 10 meters per second squared, so that would be 120 times cos of 60 degrees, and then 2 minus this equals x. So x is about 0.7 meters. So now looking at our back at our diagram, we know that x equals 0.7 meters. So this portion of the rod will be 1.3 meters. So we can say that the center of mass of the rod is 1.3 meters from the ground.